Good morning, Cohort 4. My name is Javier Rios. I am the District Engineer for the Linden County Water District. I was asked today to come and speak to you guys and give you guys a virtual tour of our wastewater treatment plant. But before we do that, I wanted to introduce myself a little bit further. I'm a first generation citizen, first person in my family to go to college. I'm really excited to share this with you guys, share my life with you guys, and hopefully give you guys hope that one day you can aspire to do the same, because it's possible. I grew up in South Sacramento. I went to Luther Burbank High School. That's where I met Martin Ramirez, and that is actually the first time, around junior year, is the first time I dabbled in the idea of becoming an engineer, and whether or not I wanted to do that. Like I said, first generation college student, first generation citizen in the United States. So, I come from a background where there wasn't a lot of help when it came to education, and the finances were pretty minimal too. So I was kind of left to fend for myself. I grew up in a house with 6 other siblings, single mom. So, it was really tough. But one of the things that my mom instilled in me, and I'm pretty sure a lot of you guys have, strong Hispanic or minority background, strong parents who instill hard work, and that's one of the things I want to just make sure that you guys always continue to work hard. Don't let any of the things that are going on in the world kind of deter you from what you want to do. Just stay positive. You're going to run into really good people. Make sure you hang on to those people, find the right mentors, and just échale ganas, keep going, work hard, and you could achieve your dreams. And I'm a prime example of that. I really came from nothing, and right now, I am living a pretty successful life. I have a wife, 3 kids, and I have the job that I've always wanted. Like I mentioned, I'm the district engineer for the Linden County Water District. We're a small public municipality. We serve a population of a little under 20,000. We provide potable drinking water. We provide collections and treatment of sewage. And that's kind of one of the big reasons why we're here today, is I want to give you a virtual tour of our wastewater treatment plant and kind of show you a little bit of what I do and the things that I deal with on the day-to-day. So let's take a tour. So welcome to the Linden County Water District. We're going to take a quick tour of our facility. We're going to highlight some of the major components, and we're going to talk about kind of what we do here. Before we get started, wastewater treatment plant is put in place in order to take what is considered sewage, raw sewage, and treat it to the point that it could be discharged to surface waters or percolation ponds, which ends up becoming groundwater. All these things are state mandated, so the sewage comes in very high strength. By the time it leaves, we meet all the state regulations, if not better, before we discharge it out to, here we have percolation ponds, but we're also right next to the Feather River. So let's get this tour started. So we're at the primary clarifier. The intended purpose here is to use gravity, which is our friend, and free. So this is a sedimentation basin, is pretty much what it is. So we allow the water or the sewage to move across at a slow pace. It's so slow that you could barely see that those launders are even moving. But what's happening here is the heavier particulates, or the heavier solid material, is sinking down to the bottom so that we can remove it here before it moves to the next process, which is the activated sludge basin. And there is where we use a lot of energy to produce air to help the microbes digest the materials that are in there. So the more we can remove here, the less money we have to spend over there. So pretty much this is just a settling tank. We're trying to get the heavier particles out before we move to the most expensive process of the plant. So let's go move on to the activated sludge basin. So this is one of the most important parts of the process, most expensive part of the process. And so this process here is all about the biological portion of the plant, how we use bugs that we culture and grow on purpose to do our bidding for us. So the activated sludge basin is broken into 2 separate compartments. We have the aeration zone, which means there's air involved, and then we have this anoxic zone here where there is no oxygen or little to no oxygen involved. And both of these environments have to be kept at optimal certain levels in order to keep these bugs alive. So in the aeration zone, what's happening is the microorganisms that we grow in there, they're kind of our super turbocharged bugs. They eat all the organic, the solubles in there. And part of that process there, in order to keep them alive, we have to supply them with oxygen. So if you look over there, there's a bunch of bubbles in the aeration zone there. And if you look here, there are no bubbles. And the reason we do that is because in the activated sludge basin side, where the air is happening and they're breaking stuff down, there's ammonia that's coming in. So this is for you chemistry freaks. There's ammonia that's coming in and it's being broken apart. And there's nitrites and nitrates that are being produced. And we have limits as to how much we can allow to leave this facility. And so what we do is we circle those nitrates and nitrites back. And in this anoxic zone, because we've taken away the oxygen for these bugs, they have to use a different source to keep them alive and keep their metabolism going. So they move down the chain and they start to consume the nitrates and nitrites, and they produce nitrogen gas, which just off gases into the atmosphere. And voila, you get rid of your nitrate and nitrite problem. One really crucial part of this process is, in order to keep the bugs alive, because they do die off after they've expended their energy and they consumed a bunch of the organics and the solubles and the foods in there, they do die off and they become waste. And what we have to do is, in the next process, which is called the secondary clarifiers, we have to recycle a certain amount of those bugs so that we keep a certain quantity of microorganisms here to do their job. So that's where we're going to be going next, the secondary clarifiers. All right, so here we're at the end of the activated sludge basins, and we are looking at the secondary clarifiers. Similar to the primary clarifier, the secondary clarifier relies on gravity to remove solids. The only difference here is that the primary clarifier's goal is to remove as much of the bigger solids before it gets into the activated sludge basin, so that we can reduce the oxygen demand that's needed for the bugs that are in there metabolizing that food waste. What we do here is that we want to create a concentration or a constant cycle of bringing those bugs back, because what happens is, as that solids or that water is being moved from one place to another, so from the ASBs to the clarifier, we lose some of those bugs, and we want to make sure that we keep a certain concentration of microorganisms inside of the activated sludge basin. So what we do is, at the bottom, once those solids have settled and the bugs have settled, we introduce some of it back into the activated sludge basin. That's called return activated sludge, so RAS. But we also concentrate it so much that we need to get rid of some of it, and that's called WAS. So that's the waste activated sludge. And that stuff at the final point will go through a thickening process and it'll enter into a digester, which we'll get into at the end, but probably the coolest part of the plant. So let's go. All right, so now we are almost to the end of the process here. What you see behind me is called a tertiary filter. Tertiary filtration is kind of the last part. It's kind of the polishing part, or the finishing touches on the water that has made its way through, or the sewer that has made its way through. As we've been moving through the process, you could see that by the time we got to the secondary clarifiers, that water was pretty clear at that point. There's very minimal solids, total suspended solids, very little turbidity in there. But what we want to do is make sure we remove it down to the requirements of our permit, and that's what these tertiary filters do. So they remove all the finer stuff that we couldn't get out in those heavier, more physical processes over there. Here you can see we have 6 filters. They don't all operate. The plant is built to continue to grow. But at some point in time, all of these will be running in the future. And so from here, after this, really all that's left is to chlorinate the water so that we make sure we destroy any pathogens, viruses, bacteria that are left in the water that could be harmful, not for drinking water purposes, but before we discharge it out into a river or into our percolation pond. So as we move forward, we'll go see the chlorine contact basins where we add the chlorine before this thing leaves the site. All right, so here we're at the final step of the treatment process. This is a chlorine contact basin. This is where we introduce chlorine. Here at the plant, we introduce chlorine in a gas form. So inside of that building, we have 1-ton cylinders. I think there's about 6 in there, ability to hold about 8 single-ton cylinders. So there's chlorine gas over there. Here, what this is created for is to create a contact time. So the size of this basin, how long the flow actually stays here before it leaves out to the percolation ponds all has to do with maintaining a certain CT, which is a contact time. And so that's how we design these, and that's pretty much the gist of it. Rolando did ask me a question about recycling, and here at the plant we do our best to recycle as much as possible. Over on the end here we have a hydropneumatic tank and a small 2-pump system. The purpose of that is that it pulls water from the effluent once it's been completely treated. It pulls some of that water and it allows us to use it throughout the plant for scum sprayers, wash down purposes, wash down hose bibs. So you'll see throughout the plant there's a lot of do not drink this water sign. So that's all the recycled water that we're repurposing here at the plant to minimize the amount of potable water we have to pay for the district to contribute here. So we're trying to do our best to conserve and be friendly to our environment. And so, yeah, that's pretty much this side of the plant. And there's really just one more thing I want to talk to you guys, and it's probably my favorite part of the plant. It's the digester, and that's kind of where the magic happens. So let's go over there. All right, so here we are at the digester. This is kind of my favorite part. It is my favorite part of the wastewater treatment process. In my opinion, the solids handling process is the most difficult to fine tune and figure out. But, you know, as we've been going through the plant, I've showed you the primary clarifiers, the activated sludge basin, the secondary clarifiers, the trickling or the tertiary filtration process. And throughout this process that we're removing solids, well, we have to figure out what we're going to do with those solids. Those solids are still very high in strength, so we call it, they still have a lot of energy left in them, and so that we can't just dispose of them into our environment. So we have to do with it something with them first. And what we have here is a digester, and a digester works very much like the human stomach. And this one here is actually called an anaerobic digester. And anaerobic just meaning we keep it within a certain temperature range, which is the human temperature range. We keep it around 98 degrees. And what that does is it produces an environment just like the bugs in our stomach. It produces an environment that's conducive for them, that helps them metabolize things just like we do. Similar to us, as they consume the food that's in the digester, they produce off gas, methane gas. And that gas, what we do here at the plant is we actually recycle that gas and reuse it to power the boilers that continuously heat the sludge to the temperature that it needs to be. We produce more methane at this point that we can use. So what we have is a flare, and this flare, what it does, it burns off the excess methane and releases that into the environment. At some point in the future, the plant does plan on putting in microturbines. And what these microturbines will do is turn that excess methane into electrical power, which we will reuse as well. So our goal here is to be as environmentally friendly as we can be. So we're always looking for ways to reuse and reduce our carbon footprint. So that's the digester, the solids handling process. There's a lot more that goes into this. I encourage you, if you're excited about it, if you ever take any classes that, you know, wastewater classes or process engineering classes, those are kind of the things you'll need in your tool belt in order to become the person that one day either runs one of these facilities or designs one of these facilities. So with that said, that concludes our tour. Cohort 4, I wish you the best of luck, and congratulations on getting into the program, and hopefully one day I get to talk to you guys when you're professionals and you're out of the program. All right, bye.